Your exam will have 6 questions, each with multiple parts. There are 20 true-false questions, 10, I don't know, 20, 10, yeah?
Do we have to back up our answer?
I haven't thought about that yet. Because I can make it 2 points each, and then I don't know how the partial credit would work for backing up answers. So maybe not. But be careful if you decide to put T, because they might all be false. Or if you put F. You can put TF if you want. Let's see what happens. But if we do a binomial distribution problem, we can figure out exactly what your expected score would be if you just guess. Problem 2 would be in Chapter 10. By the way, Problem 1 is in all the chapters. Problem 2 would be the calculus of parametrized curves and polar coordinates in Chapter 10. Conic Sections was in Chapter 10, 10.3. Vectors was in Chapter 12. And lines and planes were towards the end of Chapter 12. And the projectile motion is taking a look at vector valued functions. That's Chapter 13. Okay. All right, we're done. I'm done. Oh. All right. Some conics, Chapter 10 stuff. All right. So, this is a page in your web access now. I had the problems to practice as the last page of yesterday's notes, but I suggested that I make a new page for this. So. Here's your practice problems that you can work on. And I basically am having you guys go to the review section of each of the chapters. And then I picked out problems. I didn't really pick out problems. They're more like eliminated problems that you don't need to know. So there's things that you should know and things that you don't need to know. I used to have 2 columns when I used to review for my exams. I would have the no column and the no column. The KNOW column and the NO column. Anyways. So we have this, yeah?
Would it be safe to assume that everything that you covered in class should be represented on the exam?
And then some. So my philosophy about tests is, well, I don't like grading them. But that's besides the point. I think my philosophy on the test is that I put a lot of the basic questions would make up about 75% of the test. And when I say basic questions, things that are absolutely necessary for you to be able to pass the test. And then there's some challenge problems, and that would amount to another 10% of the test. And so if you're able to get the basics and some of the challenge problems, then you're hovering at about a B level. And then there's some extra challenge problems, about 10% of the test. And you know, that would be the level of the A student in taking the exams. So that's kind of like my philosophy, more or less. And so that means at that A-level portion of the exams, there might be some things on the test that were not covered in class, and the homework may have touched on it a little bit, but it's extending your thinking abilities to just a C-level work. Okay, so that's how usually I design my tests. And in the past, I used to have a take-home portion of the test where, you know, you get to take it home, and the problems would be a lot more difficult, things that would be really, really difficult to do in the class in a timed situation. So I normally would give a take-home portion. But over the past few years, I've noticed the take-home portions have, you know, stacks of them that have the exact same answers, exact same wrong answers and stuff like that. So I've cut back on take-home portions of things and just kind of expected you to have the basic knowledge of the course so far and be able to explain to me that you can do the basic stuff. Yeah?
Should we expect a format similar to the quiz where they all sort of build off of the first step?
I tried not to do that. I think there's one problem where I couldn't avoid that. But most of them would have different parts, and the different parts would not be related. Okay? All right. Any other questions? Now, I'm not saying all this stuff to scare you. I mean, I want you guys to do well on the test. So for some of you who have never taken my class before, you should know, you probably know a little bit about me already, but you should know how I give exams before you actually get the exams. Good luck. All right, we want to go to Chapter 10 and take a look at some conic sections and some other stuff, so let's do that. I don't know if you want to do review questions or just jump around to different sections. I don't want to choose. Okay, a couple examples, true, false, and then some conic sections. I don't know. What should we pick? Oh, that's concept check. All right, let's start off with maybe just a handful of true, false questions.
Oh my gosh. Yeah, what is happening?
The parametric curve x equals f of t and y equals g of t satisfies g prime of 1 is equal to 0. Then it has a horizontal tangent at t is equal to 1.
Yes.
Is that true or false?
True. Oh, just kidding. It could be, oh, no, it could not. Yeah, no, yes. That's what yeah.
All right. For those people that say it's true, why do you think it's true? What? So the tangent is dy dx, the slope of the tangent line, right? That tells you if it's 0, then it's horizontal. According to one of our formulas, the derivative is given by, since these are functions of t, it's given by dy dt. So g prime is the y, and then f prime of t. So at 1, when t is equal to 1, if g prime of 1 is equal to 0, then it looks like this whole fraction is going to be equal to 0, right? So it looks like it's true. Who said it was false? Who said it was false? Okay, the correct answer is false. Why? Yeah, so if the value of f happens to also be equal to 0, then what? Then you have a L'Hopital's rule situation where it could be 0, could be undefined, or it could be a number. So then we really don't know.
This is so tricky. Right? It's really tricky.
Yeah. It is tricky. So the correct answer is false because we only have information about g prime of 1. We don't have any information about f prime of 1. And f prime completes that fraction. And so if f prime is also equal to 0, then we don't know what the whole actual derivative is equal to. If f prime was 1 is greater than 0, if f prime was 1 is equal to 15 or any number, then for sure you know that that's going to be 0. Okay? All right. That was a good warm-up. X is equal to f and y is equal to g, and it's differentiable, twice differentiable. Then the second derivative of y with respect to x is equal to the second derivative of y with respect to t and second derivative of x with respect to t. True or false? False. Why? What's the formula? So this would be like a formula that like you would have like in your sheet of notes, maybe. So the derivative of this, I don't know what it is, but it's in the book. It's not this, so it's false. Well, you probably should write the actual equation because you will have it in your notes, right? So this is also false. All right, the third one, the length of a curve x, where x is equal to f of t and y is equal to g of t from a to b, is equal to this integral from a to b of the square root of f prime squared plus g prime squared dt. True or false? If a point is represented by x, y, and Cartesian coordinates where x is not equal to 0 and r theta in polar coordinates, then theta is equal to the tangent inverse of y over x. Is this true or false? Who said false? No? So the tricky part about this and polar coordinates in general is that, yeah? Tangent is only defined between negative pi over 2 and pi over 2. That's one possible reason. Anything else? That's one possible reason why this is false.
Oh, shoot.
Anything else? No? We're going from Cartesian, and then now they want to know how the r theta is going to look like. So the thing about theta is that there's no restrictions for theta. So I can add 2 pi to this, and then it would still give me the same point. Or in fact, I can make this go to opposite of where it's supposed to be pointing, and then let the r be negative, and it would still go to the same point. So the idea is that there's a lot of representation when you change from Cartesian coordinates to polar coordinates. There's a lot of representation that would give you the same Cartesian point. There's a lot of representation for the polar coordinates that would give you the same Cartesian coordinate point. So I would have to think that that's false. Okay? Yeah. So it's, I mean, not other coordinates, but you still be in the third coordinate. Yeah. So if they had restrictions on theta here, then you would say that this is probably going to be true. But if there's no restrictions on theta, then you can go plus or minus 2 pi n or whatever. You know that in trig, right? When you find solutions for these things where we're solving for theta, there's a lot of different solutions. All right. Yeah, Brian?
Like if your x and y was like -3, -2, and inverse of 3 or 2.
Which is not in the fourth quadrant, right? You're supposed to be in the fourth quadrant. So this is, it's a formula, but it's more of a guide, and you have to do a little bit more trig analysis to actually get the correct angle. All right, we better stop doing true-false questions for a while. Let's do some problems now. What do we want to do?
Let's do a conic section.
A conic section to start with.
Are the answers to the true false?
I don't know. Well, you're looking through the back. Conic.
Yes, they are.
So, by the way, I may take directly from the true-false section, or I might change it a little bit. So, it's, yeah. So, just to let you know. Yeah, I mean, you can memorize it if you want, but I don't know how useful that's going to be for the test. You know, I never believed in memorizing, which is why I allow sheets of notes for the test, because I don't expect everybody to memorize everything. What are we looking for? Conic sections. Something like, I don't know, like what? Yeah, so. Well, I forgot what's on it. Which one are we going to do?
48.
So let's do number 48. And they want us to identify the foci, directrix, and all that stuff. Might as well graph it too, right? So I'm looking at this and I'm seeing an x squared, and I'm looking at this and I'm seeing a y squared. So x squared and y squared together tells me that this is either going to be an ellipse or a hyperbola. It's not a parabola. It probably doesn't look like a circle, but still might have a chance to be a circle. No, it's not a circle because the coefficients are 25 and 4. So they both have plus in front of them. So that probably will tell me it's an ellipse. So what I'll do is I'll group the x's together. 25x squared plus 50x. And then I'll group the y's together. 4y squared minus 16y. And I suppose I can just leave the 59 over to the other side. And then I will factor out common factors where they have the same variables. So I'll take a 25 out of the first one, and then I have an x squared, and 25 out of this is 2, and then I'll leave this blank, and then I have a 4. I got a y squared, take a 4 out of 16, and then leave that blank, equal to 59. And then this is where I try to figure out how to complete the square. First one, what do we add? We add a 1 here, but we're actually adding a 25 times 1. And then the second one, plus 4, and we're actually adding a 16. So now we got perfect squares. X plus 1 quantity squared, y minus 2 quantity squared, and then this business, 100. And then now to make it really look like an ellipse, right, we want to divide out by 100. So we got x plus 1 quantity squared divided by 100 into 25 4 times. So we'll write 4 as 2 squared just so we can identify our A, B, and C. C? Yeah. Y minus 2 squared, dividing out 100 into 4 is 25. And then we have 1. So it looks like the very center of this ellipse is what? Center of the ellipse is -1, 2. That's your x naught, y naught. We need to identify a few things before we can do the foci and directrix and stuff like that. A is equal to 2 and B is equal to 5. So that's why we want to write it as something squared. And so yeah, so this is where the book switched the B and the A. I don't know. I don't like that. Major and minor, yeah. Well, see if we can still figure out the foci information. There's a C involved here, right?
Yeah.
So what's the formula?
It's the bigger one squared minus the smaller one squared.
So B squared minus A squared in our case because B is bigger. And so C is equal to the square root of 25 minus 4. Square root of 21. So that's what C is equal to. And then we need to figure out the foci and directrix from here. So I don't know. C is
It's plus or minus. So you take your
yeah.
yeah. So
All right. If we take a look at the graph of this, let me graph this before we go on because
no, you take your origin and you do plus or minus whichever way is
to the focus, yeah. So I see those are the formulas that I don't have memorized, and I kind of depend on the graph to draw this. So I'm going to go to the center point at -1, 2. I know that's going to be the middle of my ellipse. the 2 and the 5 over here help me draw the major and minor axes. So along the x, this is the number along the x, the 2, I'm going to go 2 units to the right, and from here I'm going to go 2 units to the left. So if this is -1, I went as far as -3, and as far to the right as +1. And then from here I count 5 units, 1, 2, 3, 4, 5 down, and then 5 up. 2, 3, 4, 5. So that's my ellipse. That's how I would draw my ellipse. Now to find all this other stuff, the focus, so the focus is going to have to be along the major axis, along where it's larger. So the focus is going to be along the y, which means the x value of the focus is going to be -1. So the foci is going to be -1 for the x-axis. And then the y-axis is going to be that complicated formula from you have to go to the middle plus the top, which is 2 plus 5, and then you subtract the c. That's where the c comes in. Right? Wasn't it like x naught? Or why not?
So it's 2 plus the square root of 21.
Is it? Is that c? Or is this c? All right, now I have to look. Oh, it's from the center. Okay. All right. Well, that was easier. So it'll be from the center, which is from, what is this again? 2. And then this measures a distance of c, and then measures another distance of c. So 2 plus square root of 21, and then 2 minus square root of 21. So that's foci. Do they want us to find the directrix too? No, it changed. What? They just asked for the foci and the vertices, so no directrix. Would I ask for it?
Which means the distance between the foci and the vertices, and the distance between all the others.
Yeah, so I don't think I'd ask for a directrix for something like this. All right, I think we're done with this one then. All right, what else? Yeah?
Oh, I was going to say, can you do the distance between 2 planes?
Okay.
Oh, yeah.
Okay. So that's next chapter. Are we
Oh,
done
you
with
wanna do this
13?
one? Okay.
Oh, we could jump around, I guess. Is there anything else in chapter 13 you want to do, or should we, chapter 10?
Yeah.
Eccentricity? All right, let's see. Eccentricity. Where would that be? After this? Where? Where?
No, we're in like 10.3 because this is older stuff. I think it's further down because that stuff is in 10.5.
So I'm in the review section.
Yeah, which it goes sequentially, doesn't it?
Yeah, but
Yeah.
now this is the end.
There's like 56 and 55.
So which one do you want to do, 55 or 56? 55?
Are those in your range?
What do you mean my range?
Your test
Your
study.
exemplary test study guide.
Oh.
That's the wrong example.
All right. Find a polar equation for the ellipse with focus at the origin and eccentricity of 1/3. Directrix has an equation r is equal to secant theta, 4 times secant theta. So what I would probably do is, I'm assuming that r is equal to 4 secant theta is a straight line. Now we just have to try to figure out if it's a horizontal line or vertical line, and see where it would be. Like if I had theta is equal to 0, I'd be pointing towards the positive x-axis. And what's my r equal to? What's secant of 0? One, right? It's cosine, and cosine of 0 is 1. So r is equal to 4. So if I were to guess, this r is equal to secant theta is actually that line x is equal to 4. And that would be my directrix. And I know my focus is here at the origin. So if you couldn't guess that, then I would just probably plot r is equal to 4 secant theta in my calculator just to take a quick look at where it might be. Okay? Yeah?
We can solve for d if we use the y equals r sin theta, and solve for r instead of making with each other.
Yeah, you could do that too.
For sin theta.
So you can, yeah, you can really, yeah, you can do that. So you could change this polar coordinate equation into Cartesian coordinates by using the r and theta replacements and stuff, and then simplify it, and you should get x is equal to 4. All right, so we have a directrix. Is this a parabola? No, it's an ellipse. Oh, the eccentricity is 1/3. So let's see. How do you do this? So we know that this is going to have the form r is equal to e times d over 1 plus or minus e times sine or cosine. Okay? So it looks like we have all our stuff here. We have E. We have D. And we have the rest of that. I don't know. Somebody said it was cosine. Yeah. So in your book, the beginning of chapter or section 10.6, 10.5, at the beginning of 10.6, they have an example of a parabola with sines and cosines and pluses and minuses. So if you look at that, you can kind of determine if this is opening upward or downward, or if this is an ellipse that has a directrix that's parallel to the y-axis, then it would be kind of elongated along the x, and then that's going to tell you that it should be a cosine. But you probably should, just to make sure, graph this. We have, on your graphing calculators, we have 4/3 divided by 1 plus 1/3 cosine theta. And if you put the directrix x equals to 4, and you remember that formula that the eccentricity is the ratio of the distance between the point and the focus, and the vertex and the focus, and the vertex and the directrix, then you'll see that this actually does make sense as our graph. Right? So the eccentricity is equal to the distance between your vertex and the focus divided by the distance between your vertex and the line. In this case, the distance is 1 and 3, so it makes sense. Okay. All right. Are we good with chapter 10? Ready to move on? What was it that we wanted to see? Distance between two planes. There's number 17.
Oh my God, can we do some true false first in this section? Yeah.
All right, pick a column, the left column or right column? Right column.
Yeah, it does. I think they're all identities.
Should we do 2 or 3 of them? All of them? All of them? All right, let's do the first one. Is this true or false? False. Turns out that U cross V is equal to V cross U with a negative in front. So this is false. How about for number 7? Is this true or false?
True.
This is true because it's the same length, just going in different directions, so the magnitude will be the same. In fact, if you think about it as a parallelogram, those parallelograms will have the same area. So, how about the next one? For any vectors u and v, any scalar k, k times u dot v is the same thing as ku dot v. True? That's one of the properties. For any vectors, doing the same thing except with a cross product. Is this true or false? True. Another property. And then next one, if you have u plus v crossed with w, then that's u cross w plus v cross w. It looks like it's a distribution. True or false? True. It's a property. So there's a bunch of properties, like when they first introduced the dot product and the cross product, there's a bunch of properties that involve those, and then it would be good to know, or at least have on your sheet. Your sheet's getting tighter and tighter, huh? All right. Well, that was easy. Okay. Distance between two planes. Exercises. Oh, there's more. Look at that.
Wait, can you go over one true false question I saw? No.
Really
It's,
quick.
Yeah, it's number 18.
Number 18. Whoops.
That's false.
All right, what's going on? Am I number 18? It's not a paraboloid. What is it? Parabolic cylinder. So along the x and the y, you have this parabola, but you put it in 3 dimensions, it really goes up. So parabolic cylinder. All right, in search for the distance between two planes. That's what we're doing. What would that be?
27.
Oh, there you go. Distance between two planes. So on your sheet of notes, you would have the formula for the distance between two planes, right?
You have to understand what
Okay. So it looks like the distance between two planes is just given by the difference between D's divided by the square roots of the normal vector, which should be the same, right? If they're parallel, they should have the same normal vector. And then you're done. So 16, 25, 26? 26? Yeah.
The D's, they come from the normal vector that the point you had to find. If you
Yeah. If you were to pick any point on this plane, why don't you guys give me a point on this plane? 0, 0. What's a point on this plane right here? 0, 0, 6? Positive 6? Negative 6? 0, 0, negative 6? Right? So that's a random point that we just chose, right? If you dot this vector, or the point, with the normal vector, 3, 1, negative 4, dotted that with 0, 0, negative 6, you should get your thing. You should get your D. So what happens when you dot this? You get 24, which is the D. So it turns out that if you pick any other point on this plane, when you do that dot product, you're going to get. Okay? So when we did this in class, we derived the formula, and that's why it kind of took a long time. But once you have the formula, then that's a formula. So you can rely on the formula. That's like the C level. Or you can know how to derive the formula, then that would be like A level. You know, just when I was talking about earlier, the test being layered. Whatever. Okay. Another one from this section or chapter? Skew. Let's see. Point, intersecting a plane, distance, origin. Oh, here they want us to find out whether this is parallel or skew. So let's take a look at that one. Would that be a good one? So it turns out that symmetric equations are not very useful. So we may want to rewrite it in vector form or parametric form. So let's do that. Let's change these into x, y's, and z's with t's in it. So we can assume that each of these things are all equal to t, and then solve for x, solve for y, solve for z. So x is equal to 2t plus 1. Yeah? Y is equal to 3t plus 2. And z is equal to 4t plus 3. So I'd want to do the same thing with the other one, but eventually I'm going to want to know, the first thing to do is to try to find out whether they're parallel, and then try to find out where they intersect. And if they're not parallel, and if they don't intersect, then it has to be skew. That's kind of like our last option. And to find out whether they're parallel, you just kind of look at the direction vector to see if they're going in the same direction. If they intersect, you want to know if they intersect at a couple of places, or at one place, at one point, but that one point might not be the same t. So this is where you would write it, instead of t equals, you write it with an s or a different variable. So let's write it with an s. Your x here is equal to 6s, and I have to write my s's funny because it kind of looks like a 5. Your s's look like 5s. So I have a little tail for my s. Oh yeah, that was in differential equations, right? So 6s minus 1, our y is equal to negative s plus 3, and then our z is equal to 2s minus 5. Look, at the s and the 5 look the same. Nope, because I have a little tail. So now if I look at the coefficients, the direction vectors here is going to be 2, 3, 4, and then my direction vector here is 6, minus 1, 2, and it looks like there's no way I can get this one to be a multiple of the other, so I think I'm all good in terms of determining whether they're not parallel. In this case, they're not parallel. Oh, man. So not parallel. Let's find out if they intersect. Let's set the x's and y's equal and the z's equal to each other. We can start off with x's. 2t plus 1 is equal to 6s minus 1. And then the y's, 3t plus 2 equals negative s plus 3. And then the z's, 4t plus 3 equal 2s minus 5. And then I'll take two equations and solve for two unknowns, and then I'll take those solutions and plug it into the third equation to see if it would give me the same answer. So, yeah. You know, do this. Anybody get the answer yet? All right, I'll do it. So 2t minus 6s, I'm going to rewrite it so that it looks like a nice linear equation. Negative 1, so this would be a negative 2 on the other side. I have a 3t plus s is equal to 3 minus 2 is 1. And it looks like if I multiply this by 6, then I can do the addition method. So I'll have 18 plus 2 is 20t, and this would be 6. Negative 6 is 0, so that's gone. Negative 2 plus 6 is positive 4. So it looks like my t is going to equal to 1/5. I'll take that t and put it into here. 1/5 plus s is equal to 1, so s is equal to 2/5. So I know at this particular timeline, the t timeline, that it's going to meet with the x and the y at 1/5, and then the s timeline will hit the same x, y values at 2/5. Now, just wondering if they're going to be the same z value. So we'll put 1/5 and 2/5 into this equation. You get 4 times 2/5 plus 4 times 1/5 is equal to 2 times 2/5. So that question is are these two things equal? This is a question mark. Well, I have 4/5 plus 3 and 4/5 minus 5. It doesn't look like it's going to be equal, right? So you don't have to find those numbers. Just if you know that they're different, then you're done. So this tells you that they don't intersect. Which means that they must be skew. Yeah.
Prove that they're not parallel and they're not intersecting. It's sufficient to say that the 2 planes are skew.
Yes, that's the only other possibility. Yeah. If they're skew, we should be able to find the distance between them, right? So let's do that. So let's find the distance. Between two skew lines, what we basically need to do is construct planes containing those things and then find the distance between them. So we have a couple of skew lines. And each of them has a plane, parallel planes that they live on. And so we need to find an equation for each of those planes. So we need to find a normal vector. And I think I need these directions. So I have the direction vectors from those planes. So I know that for one plane, I have a vector on that plane. And for the other plane, the other line, I have another vector for that line. And so, and if we move them around, they're essentially on the same plane direction. And so if I cross them, then I should get the normal vector that's perpendicular to both of them. So I just take these two vectors and then I cross them. So my normal vector will be the cross product of D1 and D2, any order. So 2, 3, 4, 6 minus 1, 2. And in the I direction, I get 6. I get 6 plus 4 is 10. In my J direction, I get negative 4 minus 24. Right? So negative 20, but then the J has a built-in negative. So positive 20. And then the K is a negative 2 minus 18. Negative 2, negative 20, right? So I get this vector as my normal vector. Now I could use this normal vector, and we could deal with it this way, or we can, yeah?
Sorry, I think it's for the J, I think it's 4 minus 24 and then put the negative in front of it. Right?
Yeah, so 4 minus 24.
Oh, yeah, I'm sorry.
Yeah.
I'm sorry. I'm so
Okay.
sorry.
So 4 minus, you guys should write this out. I'm doing it fast because you guys are correcting me. When you guys are taking your test, nobody's going to correct you except for yourself, so make sure you take your time. So I'm not doing it fast because I can add fast because I can't add fast. I'm doing it because you guys are correcting me. So remember that when you do this on the test, don't rush. Just, write it out if you have to. Write down 2 times 2 minus 6 times 4, whatever it is you need to write down just to be meticulous about it. Anyways, this n vector, it turns out that your n is your normal vector, and the only thing that's important about the normal vector is the direction. So it looks like these things are all multiples of 10, so I can just factor a 10 out, and that would give me a new normal vector. So I'll call this n1, and that would be 1, 2, negative 2. I think 1, 2, negative 2 is easier to deal with than 10, 20, negative 20, which would be fine too, but either would work. What do we need for equations of a plane? A point. So we need a point for each of these planes. So I think this one's going to carry 1 point, and then this one's going to carry another point. All right? And can you give me a point real quick just by looking at the parametric equations?
1, 2, 3.
So if you let t equal 0, if you let s equal 0, you'll get a point on those lines, and those points will be on those planes. So for the first plane, the purple plane, we have, let's call it D1. And that's just, remember the D is a dot product between the normal and any point on the plane. So we have a normal vector, any point on the plane is this. So 1 times 1, 2 times 2, that would be 4. And then 3 times negative 2, minus 6. So D in this case would be negative 1. And then we'll do the same for this one. We have negative 1, 3, negative 5 for your point. So the D for this one, I'll call it D2, is negative 1 plus 6 plus 10, and that is equal to 15. So our equations for the first line is going to be the coefficients are normal. So 1 times x plus 2y minus 2z is equal to the d1 that we found, which is negative 1. And the second plane will have the same coefficients, same normal, except the d will be different. In this case, it will be 15. So we want to find the distance between those two planes. And then the distance then is just going to be the difference between the b's. So the distance equals, it doesn't matter the order because you're going to take the absolute value anyways. Just be careful if you have a negative in front of one of those. And then you divide by the magnitude of that. Okay, then simplify. Now, if you didn't scale this down to 1, 2, negative 2, you kept it as 10, 20, negative 20, just follow through that either in your head or actually do it later on. You'll see when you take the D, that would also be scaled by 10 for both of them. And so when you write your equations, this would be 10x plus 20y minus 20z is equal to negative 10. 10x plus 20y minus 20z is equal to 150. And then you do this distance, and then those things will cancel each other out. So you'll get the same answer. Well, there's no plus and minus. This is just a plus. So distance will just stay positive. Just stay positive. Oh, we're out of time. So good luck studying. Yeah, good luck. I don't know what else to say.